Hello everyone, this is Sopan Chavan. I welcome all the participants to this Edmodo class. Today we are going to see what is the sequence of a real number. So let's go to the Edmodo class. This is the interface of your Edmodo class. So in this interface, go to the folders and then go to the semester third, and in this semester third there is a folder of notes. So these are the notes of sequences. So today we are going to learn what is sequence, then what is a real sequence. After that we will learn the range of sequence, then the notation for the given sequences. After that we will learn some methods to write the given sequence, and lastly we learn some examples of these sequences. So let's go to the first chapter, sequences. So first we define what is a sequence. Friends, let's take one set of natural number and let's take another, this capital A, to be a non-empty set, and define a map from S from set of natural number to capital A. So this mapping S is called a sequence in A. I hope you understand the sequence in A. So let's take, repeat. N is a set of natural number and capital A be the non-empty set, and define a map S from set of natural number to non-empty set A. Then this mapping S from set of natural number to A is called sequence in A. Friends, the sequence can be finite or infinite. When the sequence S is finite, if the domain of this sequence S is finite. So here the set of natural is infinite set, so this sequence is infinite sequence. But if the domain of this sequence S is finite, then this sequence S is called a finite sequence. So let's take one example. So this is your finite set. This set contains an element 1 comma 2 comma so on n. And what is the image of this set? The image of this set is S of 1, S of 2 and so on, S of n under S. So this is the image set of this set. This is your domain and this is your codomain. So S from this set to this set is a sequence in this set, and this is a finite sequence. Why? Because there are finite numbers in this domain set. So this is a finite sequence. So remember, if the domain of sequence, if the domain of a function is finite, then that has to be a finite sequence, right? So let's define a real sequence. What is meant by a sequence to be real? It means that a sequence of real numbers. Okay, so we have defined a sequence in A. Instead of this taking A to be a randomly, to take this is a subset of set of real numbers. If this A is a set of real numbers, then this S from set of natural number to A is called a sequence of a real number. What is the sequence of real number? A function S from set of natural number to the set of real numbers or a subset of a real number, then that S to be a sequence of a real number. Okay, so let's define the range of sequence. Friends, we know that the range means the image set of domain set. The image set of elements in the domain set. So this is your mapping from set of natural number to A, and the S defines on the elements of natural numbers, and the image of elements of natural numbers are in A. So the image elements are like S of 1, S of 2 and S of n. So these there are infinite elements in the domain set 1 comma 2 comma so on n comma so on up to the infinite. Okay, so the range set is what? The image of 1, that is S of 1, the image of 2, that is S of 2, and so on. So this set, the image set of this is this set, and we write this set as R of S. This is a notation for your range set. Actually, this is the range of this S. So range of this S is what? The image of the elements in the domain set, and this is your range of S. Okay. We call the nth S of n is the nth term of this sequence. There are infinite elements in this sequence. So this is your first term, this is your second term, and so on. This is your nth term, and so on. So this nth term S of n, we call S of n, we call the nth term of this sequence, and we write in traditional notation this S of n as Sn, S suffix n. Okay, so if we write this S of n as Sn, then your R of S is what? Your R of S is in curly bracket S1 comma S2 comma so on Sn, and then so on. So actually this is your sequence. So let's come to the notation of sequences. Friends, sequence can be written in different ways, such as, in curly bracket Sn. This is one notation for the sequence. We can write sequence as in curly bracket Sn from n running from 1 to infinity, because the terms of the sequences are infinite. So this is again a notation for a sequence. In parenthesis Sn. So this is another notation for a sequence. And these are the three notations, and fourth notation is in this angle, left angle and right angle Sn. So these are the four notations for the sequence Sn. But this is a confusing notation for a sequence, because we write this in curly bracket, we write this set. So for sequence we cannot use this Sn. So we use this fourth notation. In left and right angle there is Sn. So this is a notation for a sequence now onwards. So let's see some methods to write a sequence. So there are three types of methods. First method is listing method or roster method. So we list the terms of sequence in order manner. For example, let S is equal to, in this right angle and left angle and right angle, 1 comma 3 comma so on, twice n minus 1, and so on. So This is one sequence, and this is a form or method to write a sequence, and this form or this method is called a listing method or roster method. Actually, this is a sequence of odd numbers. So see, 1, comma 3, comma 5, comma so on, twice n minus 1, these are the odd numbers, and this is a sequence of odd numbers. There are infinite odd numbers, so this is an infinite sequence of odd number, but we write this sequence in a listing form. We can write this sequence in tabular form, builder form or rule method also. So this is one example for this listing method. Let's take another example. T is equal to 1 upon 1 square, comma 1 upon 2 square, comma 1 upon 3 square, and so on. 1 upon twice n minus 1 square is comma so on. This is a sequence of reciprocal of square of natural numbers. This is what? A sequence of square of reciprocal of square of natural numbers. And this is again an infinite sequence, and we write this reciprocal of square of natural number in listing form, that is order manner, right? So this is another example for this roster method or listing method. Let's see the another method, set builder or rule method. In this method, we specify the sequence by rule or formula for the terms of Sn of sequence. So let's take one example. So Sn is equal to twice n minus 1, comma n belongs to n. So this S is a sequence and sequence of odd numbers. So see, we write this sequence of odd numbers in a builder form, that is, we have ruled this is a twice n minus 1 and that n from set of natural numbers. So put the values of n here, you will get this is a sequence of odd numbers. So first put n is equal to 1, we get 1, then n is equal to 2, then this will be 3, comma so on. So this is one method to write the given sequence in a builder form. So this sequence and this sequence is the same, but the method to write the given sequence is different. So again, write this sequence of reciprocal of the square of natural numbers to the setup builder form. Set builder form is what for this sequence? So let's T is equal to n right left and right angle 1 upon n square such that n belongs to n. So n belongs to n means what? N takes the values of set of natural numbers, and the values of n are 1, comma 2, comma so on up to infinite. So this set is again this sequence is again an infinite sequence, and this is same as that of this T. The only matter is what? The writing method for the sequence is different. So next is inductive or recursive method. In this method, we have S1 is given, then Sn plus is given for n greater than or equal to 1 by formula in terms of Sn or S1, comma S2, comma so on Sn. It means that your Sn, S1 is given, again Sn plus 1 is given in terms of Sn or S1, comma S2, comma so on Sn. Means Sn plus 1 is equal to the whatever value is given in this form, the terms of S1 comma S2 comma so on Sns. In this notation, above sequence is specified by S1 is equal to 1, Sn plus 1 is equal to Sn plus 2 for n greater than or equal to 1. Or we can write this Sn plus 1 as Sn plus twice S1. So this is a third method, that is a recursive method or inductive method. Okay. So let's take illustrations or some examples of these sequences. So S is equal to this Sn, that is a sequence Sn, and Sn is given, that is a minus 1 raised to n. So let's put the value of n. N is a natural number. So let's put the value of n. You will get a sequence minus 1 comma 1 comma minus 1 comma 1 and so on. So this is an infinite sequence, but the range set is what? Range set is R of S. R of S means in this R of S contains S1 comma S2 comma so on. It means that the first term of S1 is what? Sequence is what? Minus 1. S2 is what? 1. The second term, that is, and third term is again minus 1, and fourth term is 1. So R of S is a set. So the repetition of this element cannot be in this set. So there are only two elements in R of S because this is a set and the repetition does not comes in this set. So this is a two element set and this is again finite. Sequence is infinite, but range of this set is what? Range of the sequence is what? Finite set, right? So let's take another example. This S is equal to twice n belongs to set of natural number. So this is a sequence of even numbers, 2 comma 4 comma 6 comma 8 comma so on. So this is a sequence of even numbers. And what is the range set for this S? Range set for this sequence is S1 comma S2 comma so on, Sn and so on. So here the repetition of elements is not there. So the sequence set is same as that of the range set. So this is the infinite set. Range of S is infinite set and sequence is again infinite. So this is the example of infinite sequence with infinite range. And this first example is what? Infinite sequence with finite set, finite range set. So let's take another example for the third method. S1 is equal to 1 is given, means the first term of sequence is 1 and nth plus 1 term is given in terms of Sn and S1. So this is what? Sn plus 1 is equal to 4Sn plus 1 for all n greater than or equal to 1. So S2 is what? Let's put n is equal to 2 here, 1 here. So S2 is 4S1 plus 1, that is 4 S2 is 4S1 plus 1 and S1 is what? S1 is 1. So let's put here, you will get S2 is equal to 5. Similarly, S3 is what? Put n is equal to 3 here, where S3 is 3 plus 1, 2 plus 1 is 3, that is S3 is 4S2 plus 1 and S2 is what? This is your S2 5. So this is 21. So first term is 1, second term is 5, third term is 21 and so on. So this is the sequence S in this recursive method. So what is the range set? Your range set of the given sequence is 1 comma 5 comma 21 comma so on 85, because the sequence of the terms are different, therefore range of the sequences terms of the range of sequence is different. So this is again infinite sequence with infinite range set, right? This is set builder form. You have given the sequence 1 minus of minus 1 raised to n upon n square, so that n belongs to n. So the terms of this sequence are, first term is what? Put the, what is s1? S1 put instead of n 1 is there. So 1 minus minus 1 to the power 1 upon 1 square, that is your s1. And what is this? This is a 2 upon 1 square, and that is 2, or 2 upon 1 square, right? So let's find the s2. Your s2 is like this, 1 minus minus 1 square upon 2 square, and this is 0 because minus 1 square is 1 and 1 minus 1 is 0. So this is 0. What is third term? The third term is 1 minus minus 1 raised to 3 upon 1, sorry, 3 square. So this is what? This again 2 upon 3 square. Then S4 is what? The minus 1 raised to 4 means 1. 1 minus 1, that is 0. So S4 is 0. Again S5 is 2 upon 5 square, and so on. So these are the terms of sequence S. So let's see here, the even terms of the sequence are 0 and the odd terms are what? 2 upon 1 square, 2 upon 3 square, 2 upon 5 square, and so on. So next term is what? 2 upon 7 square. And what is the range set in this range? What is the range of S? Range of S is 0 comma 1 upon 2 upon 1 square, 2 upon 3 square, 2 upon 5 square, 2 upon 7 square, and so on. Because 0, repetition of 0 does not comes in this set, because this is a set. So this is again an infinite set, infinite sequence with infinite set. So I hope you understand all the examples for these methods. 3 methods, that is listing roster method, set builder or rule method, and third is recursive method. So I am signing off. Thank you.